Alright, so we're gonna try to synthesize some textures using a 6-year-old method, although it's still relevant to some extent. And I had previously tried to use TensorFlow Hub, but it turns out with TensorFlow Hub you can't access intermediate layers. So that didn't work out. So yeah, so we're trying to implement this paper from 2015, texture synthesis using convolutional neural nets. And the idea is you have some sort of neural net here trained for image classification, and like we're going to input a texture. And you then, for each intermediate layer of activations, you compute the gram matrix, which is the inner product between all pairs of filter maps within a single layer. And then to generate a texture, you're going to use the same neural net, and you start out with white noise, and then you compute the same gram matrices over, and so like your total error is like over multiple layers. And you do gradient descent, you backprop to the pixels, and then after so many rounds of backpropagation, you're supposed to end up with a texture that is not identical to the input, but looks like the input. I mean, it looks like the same type of texture. So we're gonna use, I think, like a small neural net to begin with. And so yeah, so we'll use mobilenet, which I don't know anything about, but support any input size greater than 3232. Okay, so I kind of got to figure out this general API. We're using Keras, obviously. And so how's this going to work? Do I need to import it separately? Or it doesn't look like I need to. Okay, so it looks like I can just say model is this, and then it looks like can the input shape be variable? I don't know. So anyway, that looks like it should work. And then we should be able to directly load or like run a test image. So let's see what that does. Whoa. It worked. And so we passed in random noise, and it doesn't think it's any category. So I guess that's encouraging. Okay, so let's actually pass in an image. No, I don't think there's... Yeah, you should be able to do that. Okay, let me quickly figure out if I can access an image like from the internet. You should be able to download an image from the internet. I know there's a way of doing this. The question is how. Okay, let me, we're gonna try to see if we can do that. Yeah, okay, so, alright, so we have to figure out if we can download an image off the internet. Python load image, like, HTTP, right? Okay, so I'll just copy paste that, and I guess I need an image. I need an image, and I mean, like, I'm also going to have to convert it to Python 3 image open. Okay. Alright, so I need to find an image. So, I think I'll just go over to Reddit and old Reddit and pics and, like, just the first image that comes up, you know? Which is, I mean, that looks like it'll be hard to classify, so... Like, a lot of these don't look like objects that would be easy to classify. Sure, we'll go with this one. Okay, is there a URL for this image? Great. So can I just directly pass this URL to here? And what is this gonna do? Okay, so what is my image? Oh, wow. Okay, so I need it as a like a small file or like a smaller image. I think they may do it here. Image. Image.load image. Okay, let's do this. Keras pre-processing import image. Yeah. So I have no idea what's happening. Can I just, like, see, I don't know what kind of, I don't know what im is, like, I don't think this is gonna work. Yeah. It's a JPEG image file. Okay, can I turn it into bytes? Or can you directly pass the URL? Yeah, no, it doesn't like the URL. Okay. So we need to turn image into bytes, I think. Bits. The entropy is from bytes. Yeah, but I need like 2 bytes. Get pixel, histogram, load offset resize 2 bytes. Amazing. It's literally called 2 bytes. So we'll see what that does. Doesn't like it. Embedded null byte. What does that mean? This might have been a bad idea. Well, what does the request do? Oh no, I think I broke my computer. Oh my god, I broke the whole thing. Ugh. Oh. Okay. Let me just, like, do this so I hit it once. So I'm not constantly hitting the server. Not that that matters, but... okay. That. And, like, what is that? Okay, it's an HTTP response. Cool. And so then you can just say, hey. Yeah. Image.open. Can I just resize this image, like, over here? Because I feel like this is, like, too large or something. Resize? Yeah, like, resize it to, like, 100 by 100, maybe? Okay. There you go, now you're talking. Now we talking. Great. Okay, so it's a big, I mean, I guess it's like, it's probably not a great image for purposes of streaming, but whatever. So, okay, 2 bytes. Right? Okay. So, or, I mean, like, I need to turn it into a NumPy array, or, I mean, I need to be able to load it into the neural net, and the Keras documentation uses this image.load image 2 bytes, target size, well, I think it's 200. And it says embedded null byte. I mean, it's like, it's already, loads an image into PIL format. We already have it in PIL format. Okay, so maybe I should not call that. And And then just pass in the image like that. Oh. Import numpy is np. Preprocess input is not defined. Yeah, that's a good point. Where's that coming from? Oh, that's for ResNet. Okay, so we don't need that. All right. I think we're good. So yeah, okay. So don't do that, and we don't need that. Okay, but I think we're good now. So X is like a numpy array now, I suppose. Yeah. And okay, so if we pass it into the model, yeah. Okay, so we're not gonna call the model. Now the thing is, I don't know what the values of the pixels it's expecting, like what format, like 0 and 1. Like, they're not going to tell you the... What are the pixel ranges? I need to know the pixel range. Okay, great. It's not going to tell you the pixel range, so... That's cool. I mean, this looks, you know, it's like between 0 and 255. Let's just say it's that. So model on X. Oh, it really wants it to be 224. Okay, see, I didn't know that. I did not know that. It literally said any image size, but whatever. Okay. I don't need this part. Get rid of that. Oh. Okay, so... are any of these probabilities... See, I don't know what the... I mean, you think it would classify it as like a baby or something? What if you say TF arg max? Right? What does that do? What did that do? What did that do? Why did it make everything 0? TF arg max. Okay. What about TF max? What? Oh, reduce max. 0.47? What are you talking about, 0.47? Wait, it was 47 what? 47. Well, actually, it would show up as 4.7 if that's the... Is there a 4.7? Oh. But... -6, -5, -5, -5. Oh, okay. Wow. Alright, so this is the largest probability. So it's giving a large probability to one of the classes. The thing is that we don't know what that class is, but like that's fine because that's not what we're here for. Like we're not here to do classification. But how would I do that though? For mobilenet call. Oh. Right. Oh. You do need to pre-process. Okay. Okay. And they did tell you the range. I was thinking they wouldn't tell you the range, but they totally did. Okay, import pre-process input X. Okay? Is that cool? No, it is not cool. Fair enough. Okay. So, yeah. Yeah, okay, but then how would I figure out what the what the things are? Classes. Yeah, I need to know what the classes are. I think basically I'm just going to get it working as a classifier and then... can you import decode predictions? And then do this. Cool, 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 cool. Hopefully this works. Then we'll synthesize textures later, at a later date. Okay. Hopefully this works. Nice. All right. That's very cool. Wait, what is the class description probability? Okay, so it's saying like a pretty low probability it's an alter, which is correct. And a bath towel and a bathing cap. Well, I mean, alter, yeah, it is an alter. I could kind of, yeah, I could see bath towel. I could also see bathing cap. So, all right, let's do another one. And then, yes, this will be kind of like a short stream, but we're doing classification with mobilenet. Very cool. I need to get some more pics for doing classification with. I was trying to like find a pic that would have like an obvious... Oh god, that thing's terrible. That would probably come up with something. Oh my god, that's the worst picture. Alright, copy the URL. Go over here, and we're going to resize it. Copy over the URL. Do that whole thing. I forgot what this is. What is all that? Oh, yeah, okay, so I can get rid of all that. Okay, so this is our image, and then we're gonna run it through mobilenet. And there's a 50% chance that it's a fly. Could be a cicada, or it could be, there's a 5% chance that it's a bee. I'll accept that. I mean, it's technically a wasp, I guess. It's a scoliid wasp. You guys like Scolid Wasp, right? We'll just do a few more here, and then my next stream, I will generate some textures. But I mean, this, you know, this is just so much fun. Okay, new one. It's gonna be a house. So, but does mobilenet know it's a house, you know? Boathouse, birdhouse, mobile home. What about top 5 predictions? Let me see here. Whatever. Okay, boathouse, birdhouse, mobile home, mailbox, Malinois. I don't know what that is. So I think it's a boathouse. I mean, it does kind of look like a boathouse, I guess, but that seems oddly specific. Look for one more here. Then I gotta go to sleep. Do 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 do. Oh, there it is. I mean, this is the standard ML input. Better get it. Better get it. Tabby, tiger cat, Egyptian cat, seatbelt, crockpot. I don't know if a seatbelt is visible. I mean, like, there should be a seatbelt there, though, so that's cool. Okay, we're gonna, yeah, we're gonna count this as a successful 30-minute stream, in which we got mobilenet running in a colab notebook. And, yeah, tomorrow we will try to, do texture synthesis using this neural net, using the mobilenet. Which, by the way, can I look at the layers? What kind of layers are we talking here? Oh, dang. That's like a lot of layers. Wow. Whoa. Whoa. Yeah, so, can I get the shape? Or like, so if I say like layer 10, can you get the shape? No. Batch norm has no shape. Well, it does. I'll put, yeah. 96. Created by layer. Keras tensor. Okay, so, yeah, let me edit this title real fast. Okay, so see you next time.